name is Samskriti, and as you all know that I am pursuing my BE degree from SVC College. So today I'm going to tell you some important topics in the subject known as microcontrollers. So let's get into our agendas, which we are going to talk about. First one is introduction. Then second is ARM instruction. Third is pipeline. Fourth is summary. So let's talk about the introduction part of microcontrollers. So what is microcontroller? Introduction to microcontroller is a microcontroller or microcontroller unit, MCU, is a small computer on a single integrated circuit. Means it is a small computer on a single integrated circuit. A microcontroller contains one or more CPUs, processor cores, along with the memory and programmable input-output peripherals. Program memory is form of NOR flash, OTP-ROM, or ferroelectric RAM is also often included on the chip, as well as a small amount of RAM. Microcontrollers are designed for embedded applications in contrast to microprocessors used in personal computers. It is used in personal computers or other general purpose application consists of various discrete chips. Like this microcontroller is basically a small computer which is having a integrated circuit. Okay, then it contains one or more CPUs. Means you can say a processor core along with the memory and programmable input-output peripherals. Means program which is having NOR flash, OTP-ROM, and ferroelectric RAM is also often included on the chip. It's working on a chip as well as amount of RAM. Microcontrollers are designed for embedded application, which you have to remember. Then personal computers or other general purpose application consist of various discrete chips. This is what microcontroller is. Our second topic is ARM instruction. So let's get into it. Explanation to ARM instruction. So first of all, what is ARM? Full form of ARM is nowadays Advanced RISC Machine. But originally it is Acron RISC Machine. It's a family of RISC instruction set architecture, means ISA for computer processors. ISA and licensed them to other companies who built the physical devices that use the instruction set. Due to their low cost, low power consumption, and low heat generation, ARM processors are useful for light portable batteries powered devices, including smartphone, laptops, tablets, computer, as well as embedded systems. However, ARM processors are also used for desktop and servers, including the world's fastest supercomputer, that is Fugaku. From 2020 to 2022. So our next slide will tell us about some ARM microcontrollers. There have been several generations of ARM design. The original ARM one used a 32-bit internal structure but had a 26-bit address space that limit to 64 MB of main memory. The limitation was removed in ARM MV5 series, which has a 32-bit address space, and several additional generations up to ARM V7 remains 32-bit. Means it was remain in ARM V5. It was removed in ARM v3 and it was there in ARM v7, 32-bit. Released in 2011, the ARM v8A architecture added support to 64-bit address space and 64-bit arithmetic with its new 32-bit fixed length instruction set. So let's move to our next topic, that is pipelining. Pipelining basically means the process of storing and prioritizing computer instructions that the processor executes. The pipeline is a logical pipeline that lets the processor perform the instruction in multiple steps. The processing happens in a continuous, orderly, somewhat overlapped manner. So let's talk about the working principle of pipelining. So in the pipelining, each segment consists of an input register that holds data and a combinational circuit that performs operations. The output of circuit is applied to the input register in the next segment. Means whatever the output will be there in the first part will work as the input in the second part of the register segment in the pipeline. Now, first step, like firstly, we are going to fetch the instruction from memory. Second is, after fetching the instruction, we will decode the instruction. Third is, after decoding, we'll execute the instruction. Then after that, access an operand in data memory. Then fifth, the last is, you have to write the result of the operation into the input register of the next segment. Like after fetching, decoding, execution, operand, access, the fifth work is, again, it will work as the input in the register of next segment. This is how it works. So here we are loading some value in R1, then load R2, add R3, R2, R1, store R3. What does it mean? First, we have to load some value in register R1. Then again, same thing for R2. We are loading some values or giving some values input in it. Then what does this add instruction do? This add instruction, what it will do, R1 and R2 we have taken as input. We have given it the values. Then adding these two registers, it will be stored. The value which we will get will be stored in R3 register. That's what is written in the fourth line, that store R3. This is what RISC pipelining system is telling. You can see here that this part, IFIEM, is repeated in the last part, fourth part. IFIEM means the same thing you have to repeat in your last step, which will be the input of your register set. So thank you for today. I hope you like my video and do subscribe it.